All right, folks. I wanted to do a quick walkthrough here. I know that CBandHunter is a really cool application, and I also know that it's a really complicated application. So I wanted to kind of sand up a little bit of a tutorial here on how to run it, or at least show that it can be run, it works, and does what it's supposed to. And I'm hoping to maybe demystify or just answer some questions in going through it. But in case you didn't know, the two things that are required just to get started, I have a project called StillSuit, and StillSuit is here under my Muad'Dib 1984 is my GitHub handle, and then StillSuit, and this will give you the basically, like, this is just to connect to the radio and give the radio the ability to be remote controlled from another application. And I just did a video about that on YouTube, so you can watch that to find out more. And the next one is GR0, which I made as an intermediary, or like a shim, to go between GNU Radio and Gero, which is a really great application, and hopefully you know about it. If you don't, it's referenced on the main branch here, and you can go to the website here and check out John Tio's project. So in our CBandHunter branch, this has some pretty complicated stuff because we're doing a pretty difficult task. So we start out with our StillSuit radio front end, and that goes into this core subbands flow graph. And all that does is it takes the stream and it duplicates it 5 times. This is not the most efficient way to do it, but it's a good way to do it when we're hunting for signals. You have subband channelizer 0 through 4, so you got 5 of them here, and I've tried to annotate some of the command line flags that you would use. Core subbands also reads from and writes to a config file. And the reason that's cool is that when the parameters here change, it will change the config file. Then when you read back, we reload the core subbands, the config file will go ahead and set these channelized subbands up, or sorry, the subbands in here to the right frequencies, so that these subband channelizers are getting the right information. This main IQ stream coming out of StillSuit also goes into the GUI, and the GUI also reads from the config file. So the reason for the config file was, okay, I open up the GUI, I make some changes, I get everything tweaked exactly how I want. And the problem is, a lot of times with GNU radio flow graphs, when you close them, you just lost all your changes that you worked on. So this way you get them saved in this config file. It does get saved into temp, so you need to copy it out of there before you shut down or reboot. So from there, the core subbands, like I said, they have 5 streams, and we have channelizers. And each of these channelizers now takes a specific bandwidth, like a subband of the stream, and splits it apart into 15 different 15 kilohertz channels, and that's where we're going to find the 10.5 kilobaud C-band burst signals. Now I know there's also the 1200 baud signals, but I haven't been able to find those so far, and so that's kind of why I made this, was to be able to start hunting around for some of those. But I am able to get the 10.5, and that's really cool. From there, from each of these socket outputs, each channel goes to a Gero. So I don't intend for you to run 75 Geros, but you could. And I don't think that the way the frequency allocation works, that would ever be needed. I don't think that all those channels would ever be occupied, but they could. And we've seen some very busy spectrum from some of the things on Twitter and other places. So wanted to make as much open to be used as possible. The subband channelizer GUI, all this does is it takes a tap off of this IQ stream going into Gero and gives you a way to visualize it so that you can make some adjustments. So that's pretty much all there is to it. I know it's still kind of a lot, but hopefully we'll be able to go through and make some progress on this. So the first thing I'm going to do in a terminal is I'm going to start up StillSuit, and so I'm just going to run, I use a B205 mini, and the down converted spectrum is from C-band, which is up in 3 gigahertz, that PLL LNB puts us down into the 1500 megahertz range. So I'm going to run 2.16. Now for right now, we have to leave this fixed. I think it will work if you change it, but I don't want to stand on that. So I'm going to run StillSuit to get my radio spun up, and it's going to run. And now my radio, this is the StillSuit portion. My radio is just publishing IQ on this socket. And so then what I can do, just to verify that it works, if I go into StillSuit, I can also run the StillSuit controller with the FFT, and that's just going to verify that I'm in fact getting spectrum. Now, if I open up the control panel, change the FFT size to like 8192, and then put some max hold on there, you'll actually see that right in here, there's some pretty good, what I would call candidates. These are definitely bursty signals. They're high enough above the noise to say that there's some kind of anomaly. And in fact, if I middle mouse click here, and I go to my data 0, and that's just the default for this blue line that's all active. If I go here to the line style and go to none, now all I see is the max hold. And so if you look here, you can already start seeing that some of these slots are getting filled in. And so I'm pretty confident that these are 10.5K bursts in this 2.16 megahertz wide chunk of spectrum. So we can turn our data 0 back on and see there's some bursts going. Maybe we'll kill the max hold. Yep, definitely see some bursts going on. Okay, so that was our sanity check. The other thing I like to do sometimes is adjust my gain to a good level, and all that does is just give me the best SNR possible. So typically on the B205, anything below 35 isn't really great, but you see there's a bit of a hiccup, like a jump when it switches gain stages, where you get the same SNR but with less noise, or better SNR with less noise. And we can even put some averaging on there too, just sort of see what's going on. Looks like we're getting pretty good level, and I'm just eyeballing this for now. So I'm going to close this. Check this out. The radio is still running. All right, so now let's move into the next portion here, the core subbands. So now I can go ahead and run from the applications directory, the apps folder. I can run the CBandHunter GUI. And look at that. Now I've changed some of the averaging up here so that some of these peaks are more prominent, but there's definitely some activity going on there. The waterfall down here will line up 1-to-1. It's a little bit shifted. If you middle mouse click here and turn axis labels on and then back off, now it'll line up exactly. So anything that you see up here, you'll see mapped down here. You'll also notice that the subbands are not filled in. That's because I haven't started the core yet. I haven't actually started this, I'm just running the GUI. So I'm gonna move this over for a sec. And then I'm gonna go into the CBandHunter modular directory. From here, I will start the CBandHunter core subbands. And there you see the subbands are now filling in. So you'll notice here that there's 5 different colored groups of lines. The middle line is the center of a subband. The left is the left of a subband. That's the right of the subband. So if I drag this over, now I'm looking at this in this part of the spectrum in this subband. Same thing over here. Let's put this one over here. Get some nice good signals here, and then I'll just distribute these back evenly. Now remember I said if you close it, oh no, I just lost all my work. No, I didn't. Because of the config file that we're making, it automatically creates itself in temp. This will read back those changes that I just made. So if I get a really good lock here, get these all nice and lined up, I don't have to worry about losing it if I close out the GUI. All right, so the next thing I'm gonna do, because I'm seeing stuff in subband 2, I'm gonna start up one of these subband channelizers for subband 2. That's going to be on ZMQ 5003, and we're going to increment these as I describe here in the README. We're going to want to increment these by orders of 16. So we'll go, anytime we're using the subband channelizer, we want to make sure that the starting port is 16 up from the last one. And I tried to make that simpler as opposed to having to type in manually, 6017, 6018, 6019. And I did that with some Python trickery in GNU Radio. So here we're going to go ahead and run the subband channelizer. And we're going to run that. I'm going to pull up the help menu just to give me a little bit of some tips here. So -P is for the ZMQ port, and we said that's 5003. I'm going to make this smaller for a second. Okay. So according to our diagram here, 5003. So that's what we want that -P to be. And then our -W will be, this one would be 7001. This would be 7016. This would be 7032. So -W, and that's just for the waterfall, the WTF. That's where the ports are going to start. And those should always be in the 7000 range. So I'm going to make this 7032. And again, for convenience, I've tried to make the like the port numbers line up. So if you do 7032 for the waterfalls, the Jero ones are going to be 6032. And we need to keep that that kind of methodology going for now. And the last thing I'm going to do is I'm going to line up my XML RPC server, and that's what gives us the ability to remote control from another flow graph, this one. And here again, so we start 5001, 5002, 5003 up to 5. So this one's 5003. The XML RPC is going to be 9003. So again, I tried to make this a little bit more user-friendly. And the sample rate, again, the default here is 2.16. We're just going to leave that. And we've covered all of our parameters. So I'm going to run that. and now it's running. This debug output is just to confirm that we've got a 48K sample rate. And I'm going to run one more flow graph, and that's going to be the subband channelizer GUI. Now here the parameters are almost the same, but they're not quite. They don't have the -J for gyro. This is strictly to read in the parameters, or read in the streams coming out of the channelizer. So I'm going to open this up, but first make sure we can see this. There we go. And this is our subband. So here you can actually see that when you set the right ports in, the flow graph GUI will automatically put the correct ports up here that correspond to the gyro instances that these are feeding. This is really exciting because the next thing we're going to do is open up a gyro on one of these, and this already tells us how to configure our instance of gyro. So I'm going to adjust the subband position just a little bit here. I'm using my mouse wheel to scroll up, and I just want to articulate that within this subband we're seeing the bursts are kind of straddling the channels now. So I'm going to scroll back down, and you'll see them just lock in into these lanes, and we've got bursts coming on each one of these. If you have a hard time seeing channels in here, maybe you don't have as good a SNR, you can adjust the waterfall here to give you higher contrast so that you can see what's going on a little bit better. I'm going to go ahead and close this because I'm happy with the way these are lined up. And remember, I can close the GUIs. That's how CBandHunter is written. The GUIs are just for the hunting. Here too, I can use the waterfall contrast if I want to get a little bit better visual when I'm doing my hunting. All right. So the last thing we need to do is open up an instance of gyro. And I'm going to open up gyro with a -S. And here's what I'm going to do. I'm going to say gyro, let's see, 6038. And I'm just going to do that for my own annotation reasons, because now up here in the top bar of gyro, it's going to say gyro 6038. So that helps me keep track of what I'm actually looking at. Now I just ran this for the first time, so it's set to listen to my voice, and I promise you I don't have any ACARS information in my voice. So I'm going to set the ZMQ audio, set it to 6038. Set this to 10.5 burst. And will you look at that? And we are getting bursts. So we know that the smaller, shorter bursts mostly just contain the access request acknowledged, the log on, log off. So why don't we do this? Let's put this one over to the side. Actually, I'm going to minimize it for now. Pop open another gyro. This time, let's do 6043, because those look like they've got the big, fat, high data content channels. So actually, let's do 6042. And okay, spoiler alert, I had already set this one up. But if we were to come into it like we did the last one, you would just be getting audio here. And so you'd come over here, open up settings, enable ZMQ audio, set it up to 6042, gyro 6042. Okay, and set it to the 10.5K burst. Boom. And we are getting aircraft IDs. We're getting the little, we're getting the sounds of Jero, which is really cool, and definitely getting a lot of information that we need. This is going to give us some of the position information and all the beautiful things that we get, flight numbers, etc., etc. So I'm running this one, but let's see if we can go double or nothing. So this is what, 60-42? 60-42. Let's look at 60-43. Okay, same thing. We're just gonna enable ZMQ audio, 60-43. And we're getting data. And you can note that these are different. They're not the same. And another thing that's really cool to be able to do is look at these channels, and it's almost, you can almost pick out which bursts are giving you which information. As they appear, you can almost say, oh wow, there was 3 in a row, there was 2 in a row. So I hope that was exciting. I certainly think it is, and I think this is a good starting point. Again, it's a highly experimental program, so we're just gonna keep rolling with it. Post on GitHub, do pull requests, post issues, let me know anything I can do to help. Thanks.